Hello, today we will talk about series. First of all, the definitions of series is that it is the sum of all terms of sequence. Like we used to study in the last videos, sequence would be a of n or something like that, equal with a1, a2, a3, and more. And series is the sum of sequence. By that, n equal with 0. A of n equal with a of 0 plus a of 1 plus a of 2 plus a of 3 and so on more. And you can see right here the way that you can differentiate between series and sequence is that when I talk about sequence, it's gonna have the bracket, this specifically bracket for sequence, and when it's for series, it's gonna have the symbols, and then also I just want to explain more. When it said in feed right here, it mean like the term. This is the function. This is the first values for n. For example, 3 n equal 1, 10 plus n. So this is the terms, which is a1 plus a2 plus a3, n of 1 is just like the start values at n equal with 1, so 10 plus 1 is 11, so that we have 11 plus with 12 plus with 13 equal with 36. Now we're talking about property of convergent series. If series of AK converge to A and C is the real number, then C times AK equal with C times with series of AK equal with A, this values times with C. Second properties, series of AK diverge then C times AK diverge at C is different than 0. Third properties, if the series of AK converge to A and series of BK converge to B, then series of AK plus or minus with BK equal with series of AK plus or minus with series of BK, and equal with A plus or minus with B, these values. For the fourth properties, is asked about AK is diverge, series of BKs is diverge, then series of AK plus or minus with BK will be diverge. From both properties third and fourth, we can conclude that if the series of AK plus with BK it equal with series of AK plus or minus with series of BK. But some of you guys gonna misunderstand that one as like series of AK times with BK is not the same with series of AK times with series of BK. Please don't misunderstand these rules together. Okay. For the fifth properties, if m is the integer and positive number, then k equal with 1 infinity ak and series of k equal with m as ak will be either both converge or diverge. However, the values will be changed. While checking for the sums, of course. At c is different than 0. The third property is that if the series of a of n converge to a and the series of b of n converge to b, so that the series of a of n plus or minus with the series of b of n converge, and this one equal with the series of a of n plus or minus with the series of n of bn, or it is equal with a plus or minus with b, which is these values. The fourth property is that if the series of a of n is diverge and the series of b of n is converge, then the series of a of n plus or minus with b of n is diverge. You use this one for comparison test. We're gonna study about this one later. The fifth property is if m is the positive number, or we say that integer, then the series of a of n when k equal with 1 integrations and series of n when k or when n equal with m of a of n either gonna be converge or diverge. So today I'm gonna talk about geometric series and telescoping series. In the next videos, we're gonna talk about harmonic series, but we're gonna study about that later. Today we're gonna just talk about these two. Okay, at first we're gonna talk about geometric series. It is can understand that at a different than 0 and r is the real number, the series of a times with r with the exponent n, if absolute of r is smaller than 1 then the series is converged and the sum of the series equal with a to the 1 minus r. If absolute of r is bigger or equal to 1, the series is diverged and the sum of the series m of n equal to 1, then a of r to the n equal with a of 1 times with 1 minus with r of m plus 1 over 1 minus r. So please don't confuse between these two. So let's do some questions about geometric series. Question A. The series of infinity of k equal with 1 of 1 k plus 1 over 5k. Question B. The series of infinity of k equal with 1 of 6 times 5k over 7k minus 1. Question C. The series of k equal 1 or k equals 0 of e to the minus k. For question D, the series of infinity of k equals 0 of 5 to k over 7k. Question A. Find as if the series is converged or diverged. Question B. Find the first term of the series. Question C. If the series is converged, find the sum. Question A. The series of k equals 1 of 1k plus 1 over 5k. So first, I want to review some things about exponent that you study in algebra. So which is just like a of b plus c just equal with a of b times with a of c with the exponent of c. By that, we can use that rules for this kind of series. 1 over k times 1 over 5k. So by geometric series, a equal with 1 and absolute of r equal with 1 over 5, which is smaller than 1, so that we can conclude this one as converged. So these three are the necessary steps that you should write during the exams. First, you have to prove that what test are you gonna use. So this is the test that's geometric series. The second one is that like you have to know what is a and what is r, and also you have to be noticed that like this one is absolute values. Seems like some series is just gonna be like negative 16 over 5 of k. And then if you don't absolute it, then there's just r equal to negative 16 over 5, which is smaller than 1. But however, this series is diverged, not converge. But the way that you do, make it converge, which is wrong. And also have to be noticed is that the exponent of the geometric series must be the same as k in the numerator and denominator. Please don't forget, like sometimes like it's gonna give you not like 1k plus 1 over 5k. Sometimes it's just like the series of k equal 1 of 2k over 5k. Then you have to do is just like the series, it just equal the series of k equal 1 of 1 square over 5 to the k with the exponent k. Like this, you have to differentiate so that the numerators and the denominators will have the same k and put it outside. So this one is the r. Don't forget that steps. And also, when I said numerators over denominators, is that's just like the functions. Like one functions over the other functions. Sometimes they just gonna ask you about a series of n equal 1, 5, 10, n, for example. So that you don't have any numerators and denominators, but you can find the n, right? The r is just equal to 10 to the n absolute. So this one is much bigger than 1. So that this one is diverge. You don't need to find like denominators and numerators. Okay. But since like there's like if the series of like one functions over the other functions, then you have to find the common exponents, which is k or n. Or n or anything else. Okay. For the second question that they ask is that they're asking for the first terms. So which means a1 it is equal with a times with r1, which is a equal 1, r equal with 1 over 5 with the exponent 1, which is 1 to the 5. However, that we know for the third questions, it is convert. So for the sums, it just equal with a to the 1 minus r, which is 1 over 1 minus with 1 to the 5. So I have 5 over 4. That is how you can do for the question A. For the question B, it is the series of k but with 1 of 6 times with 5k over 7k minus 1. So then this one is the same as like the first one that we do. This one equals series of infinity of k equal 1 of 6 times with 5k over 7k times with 7 times with minus 1. So because it's minus 1, so we can move it up to the numerators. So this series gonna be equal with k equal 1, 6 times 7 times with 5/7k. And by geometric series, we have absolute of r equal with 5^7 absolute smaller than 1, so that this one is converged. A equal with 42. The first terms, this is the answers for number 1. The second question is that finding the first terms, which is a of 1 equal with 6 times 7 times with 5/7. K is 1, so that we have is 30. The third question that they ask, since this is converged, the series is converged, so that the sum of it is series of 6 times 5k/7 of k minus 1 equal with a over 1 minus r, which is 42/1 minus with 5/7, which is 1, 4, 7. For the question C, the series k equals 0 of e to the minus k. So we know that e to the minus k equal to the series of infinity of the series of k of 1 to the e to the k. So that we know 1 with the exponent of any numbers gonna be 1 only. So that we know that the series of 1 over e to the k equal with the series of 1 over e everything over k. So by geometric series, absolute of r equal with 1 over e absolute, which is smaller than 1, since e is just 1.7 something. By that, this one we can conclude the series is converged and a equal with 1. How do you know a equal to 1 even it doesn't happen here? Because everything times with 1 equal with that numbers. So this is the question 1. Question 2, they're asking you for the first terms. So a of 1 equal with 1 over e, which is approximately 0.3678. The third question that they're gonna ask is that if the series is converged, find the sums. And you know this one is converged, so that the series of e to the minus k equal with a over 1 minus r. And a, we know that this one is 1 over 1 minus with 1 over e, with approximately around 1.582. For question D, the series of k equal 1 of 5 2k over 7k. So this one is just equal with the series of infinity of k equal 1 of 5 square over 7 everything over k, which means the series of k equal 1 of 25 over 7 to the k by geometric series this one gonna absolute of r equal with absolute of 25 over 7, which is bigger or equal to 1, so that the series is diverged, and a equal with 1. Since we don't have any numbers time with the series, so that we can conclude a equal with 1. For question 2, they're asking for the first terms equal with 25 over 7. N equals some numbers.